Hello and welcome to the Year 9 test. Question 1. We were asked what number goes into the shaded box. It's a question about bounds, looking at upper bounds and lower bounds. We're told that we have the number 11.4 and that it has been rounded to one decimal place. If you round something to one decimal place, you are rounding it to the nearest tenth. Think of it as being in the tenth columns. As a decimal, that gives you 0.1. Now, following the rules of upper bounds and lower bounds, we know that once we've got what it's been rounded to, in other words, the nearest 0.1, we divide that by 2, and it's this value that I add and subtract from the 11.4 to work out my upper or lower bounds. So your calculations look like this. Your upper bound will be equal to the 11.4 that we had added to the 0.05. We've not been asked to work it out, but if we were, the lower bound would be 11.4. This time we would take away our 0.05. But in either case, upper bound is that's why the answer is D. On question 2, we've been told a field is in the shape of a rectangle. The width of the field is 28 meters, and that's measured to the nearest meter. We've also been told the length of the field is 145 meters, measured to the nearest 5 meters. Can we work out what the upper bound of the field would be? Well, to work out an area, that's just length times width, but let's have a look at some of the things which we've been told about. 28 meters, if we measure that to the nearest a meter, to the nearest 1 meter, if we divide that by the 2 again, we get 0.5 meters. That's what we need to add and subtract from the 28 meters. So if we add on the 0.5 meters, we get our upper bound of 28.5 meters, and if we subtract the 0.5 meters, we get our lower bound of 27.5 meters. When we're looking at the 145 meters, here we've measured it to the nearest 5 meters. So again, following our rules, we divide that by 2, always divide by 2 to find out what we need to add and subtract. And we add on the 2.5 meters to find the upper bound, and we subtract the 2.5 meters to find the lower bound. Our upper bound will be 147.5 meters, and our lower bound will be 142.5 meters. To work out then the upper bound, that's the biggest value that the area could be, we need to take the biggest width of the field and multiply that by the biggest length of the field, which is seen here as part C. On question 3, we're asked to work out the area of a trapezium. You've got two ways of doing that. The classic exam way is the one with the green by the side, where you're told a formula. Half, then a plus b, which are your parallel sides, and then times that by the h. So you do the half times the sum of the parallel sides times by the h. Or you can look at this with the blue star by the side of it, which is a word way of expressing the same thing. Half the sum of the parallel sides, in other words, add together the parallel sides first, and then half them, and then times it by the distance that's between them, which is this 7 here. Whichever method you use, we don't need this 4 centimeters on the side to work out the area. I'll use this one, just so you can see how it's being done. The parallel sides are the 9 centimeters and the 15, and the height, the distance between those parallel sides, is the 7. So if you do the bit in brackets first, and all this means is that all 3 bits are multiplied together. The half times the 24, so half of 24 is 12, times by the 7 at the end, giving me the answer of 84 centimeters squared, because it's my area, giving me answer A. On 4, we're asked to work out the volume of a triangular prism. When you have a prism, you need to know the cross-sectional area, and for a prism it's the area at the either ends, and then you need to be able to times that by its length, in this case 15 centimeters. So let's break that down into two parts. First of all, let's work out the area of that triangle at the end. We know the base is 4 centimeters, highlight that in blue. We know the height of this is 5 centimeters. This is basic. Find the area of a triangle. Half the base times the height. Half of 4 is 2. 2 times 5 is 10 centimeters squared. To work out the volume then, we take our cross-sectional area, the 10 centimeters squared, and we times that by the length, the 15. Question 5. We're asked to work out what 700 centimeters squared is in meters squared. We first of all need to know that 100 centimeters makes up 1 meter, and to go from centimeters to meters, you would have to divide by 100. Now, because we're dealing with area, it helps to draw up a quick rectangle where the area of that rectangle is going to be our 700 centimeters squared. In order to get the dimensions for that, if you choose one of the dimensions as 1, in this case 1 centimeter, then the other dimension will have to be the 700. 700 times 1 makes the 700 centimeters squared. Now all we need to do is change each of those lengths into meters by dividing those by 100. So 700 centimeters becomes 7 meters. 1 centimeter, if I divided that by 100, becomes 0.01. To work out the area then, I just do my length times the width, 7 meters multiplied by the 0.01, giving me the answer 0.07 meters squared. So the general idea behind this is get a rectangle where the units are in the centimeters that give you the area you want, in our case 700 by 1 centimeters. Change both of those lengths into meters and then work out the new area by timesing those meters together. On 6, we're asked to change 1 meter cubed into centimeters cubed. Again, from our lengths, we'll know that 100 centimeters is 1 meter. We'll also know that to change from meters into centimeters, we'll need to multiply that by 100. Right, similar thing to the one before. Sketch out a cube. 1 meter goes back by 1 meter, has a height of 1 meter. Change each of those into centimeters. Now my volume, which gives me answer A. Again, the idea behind this is create a cube in this case, because we're looking at meters cubed. Change each of those lengths into centimeters and then rework out what that would be in terms of centimeters cubed. On 7, we're asked to work out the circumference of the circle and to give our answer to 1 decimal place. The circumference of the circle is going to be either 2 times pi times the radius, or you can do it as the circumference is pi times the diameter. In our case, we've been given the radius, so I should do that. 2 times the value of pi times the radius, in our case 4.3. Type that in on a calculator. Change that to a decimal. 27.017. Some extra digits came after that, but we want to round that to 1 decimal place, which is answer C. On question 8, we're asked what is the circumference of this circle in terms of pi. Again, our two formulas for circumference are 2 times pi times the radius, 2 pi r, or circumference is pi times the diameter. Here we've been given the radius of 8 centimeters, and so I will use this formula here with the radius in it. Note my question says give it in terms of pi, so they expect pi to be in the answer. Now this is often a non-calculator question, and so we would take the 2 times the 8, which makes 16. I've still got the pi in there. And 16 times pi would be written like this, 16 pi. Think of algebra. If you had 16 times x, you would write 16x. That then becomes my final answer, which is answer A. On question 9, I've been told if a circle's radius is 5 centimeters, what is the area of the circle? Give your answer to 1 decimal place. So the area is pi times the radius squared. Pi in this case remains as pi, and the radius in this case is 5. So that becomes my sum. On my calculator it's typed as shift pi times pi, the radius squared. Pressing the equals button gives me 25 pi, gives me 78.5398, and some other digits. I'm asked to do this to 1 decimal place. It's an area, so the units are centimeters squared, and that's what I've got for answer A. On question 10, we're told a circle has an area of 30 centimeters squared. Can we work out its radius? Give the answer to 1 decimal place. So the area is equal to pi times by the radius squared. Let's put in the numbers we have. Place the value for A with 30 because it has an area of 30 centimeters squared. Pi is a number that our calculator knows, so we don't have to worry with that. And then we're going to multiply that by the radius squared. To work out what the radius is, I have to divide both sides by pi. See what happens. If I divide the 30 here by pi, I'm left with 30 over pi. My equals sign still stays there. If I now divide the pi times r squared by pi as well, pi times r squared, divide all of that by pi, these pi's cancel out. Pi divided by pi, or the same thing divided by the same thing, is 1, and 1 times r squared will just make r squared. So that's what happens for my next line of working out. The 30 over pi stays there, and I'm left with pi divided by pi is 1. 1 times r squared is just r squared. I now need to get rid of this square here, and I do that by doing the opposite of squaring, which is square rooting. So I square root both sides. So if I take the square root of this side and the square root of this side, my maths looks like this. Square root of 30 over pi will be equal to this square root here and this square here are inverse operations of each other, and so cancel each other out. What I'm left with then is just the r. What I'm left with is just the r. Type that into my calculator. The square root, press the fraction button because I have a fraction to put in there. The top number is 30. The bottom number is pi. 3.0901. 3.0901 with some extra digits. I've been asked to round this to 1 decimal place, which is answer A. Okay, please feel free to email your teacher if you need any extra help with any of these questions. Thank you.